Hello and welcome to our latest webinar. I'm pleased to be joining the Beckhoff UK team here in Huntingdon with the UK Technical Centre, where we're going to be looking at the latest developments of XTS and GFX, and really this is a deeper dive than we've looked at before. So we're going to be covering track management system, the Agile system. We've got high drive, we've got NCT, no cable technology. This is all really exciting stuff that's really pushing the boundaries. So as always, today is going to be as interactive as possible. So we want your input. Crucially, we have a Q&A section at the end of the presentation. So we want you to drop your questions in. There should be a button down the bottom of the screen somewhere. So please drop them in anytime. And when we get to the end of the presentation, Chris, who will also be joining us, the XTS technical expert, will be coming in and making sure that we can answer your questions to the best of our ability. So yeah, many of you will have seen me before. My name's Alec. I'm the International Sales Manager for HepcoMotion. I've been with the company for 20 years now. My expertise is in mechanical engineering, but I've been working with the GFX system now for several years, done multiple projects. Really love the product. But yeah, beside me is Brad.
Hi, so my name's Bradley McEwen. I work for Beckhoff UK. I'm one of the business development managers. I've been working with XTS since its introduction, so we're into our 13th year, I believe now, and I've been part of the sales and technical process of delivering these to key OEMs and end users.
Yeah, so this has really been a sort of quite an interesting collaboration. We've got sort of technologies at the sort of opposite ends of the spectrum in terms of mechanical and electrical, and we've brought those together to make these wonderful transfer systems that we see behind us today. HepcoMotion, we're experts in mechanical linear guidance systems, and we're most famous for our V-Guide solutions, which we've been doing for over 50 years now. And you know, we've combined linear technology with circular technology, which is really what we've done with the GFX system, Guide for XTS. So first of all, I mean, there'll be some of you that have joined us today, and thank you, by the way, for all of our international sign-ups. Great to see so many people from all over the globe joining us. But the XTS technology, I guess, Brad, you know, that's where do we start with that? What is XTS technology for those who may be not so familiar with it?
So firstly, I'd like to just have a brief conversation about Beckhoff Automation. Beckhoff Automation are an automation company who base their automation on very fast, high-end PC solutions. That fast PC solution has enabled us to bring some unique technologies to the marketplace, and one of those is XTS. So essentially, an XTS in its makeup is a mechatronics product, is a series of magnets, feedback and track systems, as you can see here. This particular one is a straight section, but we can do various geometries and curves. We'll go into that in a little bit later on in the presentation. But then we have a series of these passive movers. These passive movers can move along the track arbitrary in any position. We can have multiple movers, and again, we'll talk more about that later in the seminar. And these movers are truly independent closed-loop devices. So these allow your process to be fully flexible. And it's the idea is moving away from fixed, pitched, mechanical transport systems. So once again, arbitrary geometries. These can be in linear or track or circular, circular with a series of movers moving around independently within your process of your machine.
Yeah, thanks, Brad. And you know, I've seen quite a few applications now with XTS, and one thing that strikes me is the dynamics of the system. And you know, they fundamentally it does quite a few things really well. One of those is reducing footprint. The other is increasing throughput, and the overall sort of intelligence of the system, which is sort of allowing for reduced changeover times in terms of tooling, because of that flexibility. But I'm quite interested. You know, there's obviously some really clever technology driving all of this. And from a mechanical engineering perspective, you know, it all seems a bit like magic. I mean, how does the sort of system actually recognise where these movers are at any point around the system, and what sort of accuracy and repeatability can you achieve with this?
So essentially, we have a PC that's running our automation platform. That might be PLC, kinematics, motion control, etc. And the XTS is just another runtime within that PC. So we have an ecosystem called TwinCat 3. Chris is going to talk a little bit more about that later on. And within that ecosystem of TwinCat 3, we have our soft drive system.
Okay. And, you know, XTS, obviously, it's works with the Hepco track system, and effectively what we've done is we've developed a steel guide track system in conjunction with Beckhoff. We started the partnership about 7.5 years ago, and essentially really what we're trying to do is extend the capability of XTS, and I think that's primarily what these two examples behind us do really well. They're showing the extended capability, but fundamentally our steel track system is highly durable. Okay, so we've got hardened steel guides, 3 or 4 bearing movers depending on the configuration, and a lightweight aluminium body mover. For me, from the mechanical aspect, one of the key sort of advantages of the design of the XTS is the opposing magnet, and the fact that essentially, because you've got a magnet on the top and on the bottom of the mover, you're zeroing out the mechanical forces that the mover sees. So from our perspective, as providing a mechanical guidance system, all we have to worry about is the payload that's being put on the system.
So that's a good point. As you can see with this piece of track that I've got here, we've got magnets running down either side, which balances the mover. So any forces are negated, and the bearing system only needs to support the mass of the mover and the mass of the load. It doesn't have to oppose any heavy magnetic forces.
So, talking about sort of loads and forces, from a mechanical perspective, I mean, I think we're looking at loads of, 6 to 8 kilos, I would say, is probably the maximum on some of our PRT2 systems. What sort of driving forces can we generate with the XTS drive?
Well, we have various different size movers, which will go from 40 newtons to 210 newtons. One of the clever things that we can do, because as I talk about our centralized control, we can electronically lock movers together to increase forces. So essentially, as we'll see with our high drive, we can lock 4 systems together, which will be 600 newtons of force.
So there's been some great examples that we've worked on together. There's one such application where I've seen the movers actually operating as a pair, as sort of grippers. Yeah. And I'm particularly fascinated by, it's effectively picking up a plastic bottle. How do you stop the movers? Well, first of all, how do you make the movers grip the bottle? Because you're effectively making the movers move in opposite directions. And secondly, how do you stop it from just squashing the bottle?
So because these are independent movers, independently controlled, we can accurately measure the current within each of the movers. So therefore, we can apply a gripping force in a negative direction to the force of the motion. So therefore we can accurately control the grip throughout the whole of the track system, and we can release it by moving the movers apart. We can then measure different pack sizes by having different gaps between the two movers.
Okay, brilliant. Well, I think hopefully that gives you a sort of a general idea of XTS and GFX. You know, it's combined technologies that are really sort of, you know, leading the market in terms of all different types of industries, you know, from automotive to pharmaceutical, cosmetics. We've done thousands of different applications together now. So that's a general overview, but next up we're going to take a look at some of the new options that we've got, moving over firstly to our high drive system.
So we have over 3,000 XTS systems running in real applications globally across the world. Currently our limitation is around about 6 kilos. However, Alex is going to talk about how we've extended that with their latest development called the high drive.
Yeah, so high drive really is a development that we've worked on to really sort of, you know, extend the capability of XTS further. We've already talked about the standard XTS and how the sort of Hepco steel guide system really sort of maximizes durability. But when it comes to low capacity, you know, we want to really maximize that. So the high drive is essentially a larger mover with larger bearings, and we can actually mechanically link multiple movers together, both on the same track, but also high drive plus, which allows us to stack one track above the other and have up to 4 movers mechanically linked. But, you know, Brad, I mean, we talk about sort of the loads, you know, load increase, but how does that actually affect the accuracy and repeatability of the system?
The short answer is it doesn't. We still can achieve an accuracy of 150 microns with a repeatability of 50 microns. Our dynamics change, of course. You've got more mass moving, so we're not moving as fast. However, it's more efficient because we're sharing the load across different coils. So it's actually a very efficient drive system.
Yeah, and just to give you an idea, in terms of low capacity, you know, we said the sort of standard system is about 6 kilos, but the high drive system, potentially we could be looking up to 20 kilograms on a single mover. Obviously, when you get to those sorts of payloads, then you have to reduce the dynamics of the system, I think both probably from a mechanical and an electrical perspective. But the other thing we can, as I said, we can mechanically and electrically link those movers together. So you've got, you know, 2 movers mechanically linked on the same track. Payload goes from 20 to say 40 kilograms. And then if you've got another track below, then, you know, you're potentially looking up to 80 kilograms. But fundamentally also, if you have the double stack track, the high drive system, it actually allows us to increase the moment capacity as well. So you can actually have your payload stacked out quite a way from your system. So Brad, I mean, how does this sort of electrical, you know, how have you increased the electrical drive force on this system as well?
Well, we have more magnets on our passive movers, yeah, so that gives us more current to deliver to the mover. But tethering the movers together is incredibly simple with our system because, as I say, with our TwinCat system, it's all running in one PC, and it's a simple gearing function. It's a simple electronic gearing function. We couple them together, they're electrically coupled together, we don't lose accuracy. The other benefit as well is that we can very accurately couple them together because we use EtherCAT down the backplane. And EtherCAT, if we know about EtherCAT, is we have a distributed clock system which couples the movers to nanoseconds.
Sounds easy. So what are we actually talking about in terms of drive force? Because we know we've got this new 10-pole mover magnet, which is fixed to the mover.
So that's 210 newtons.
Okay, and that's a peak force.
Peak force, 210 newtons.
So yeah, we're looking at what 800 newtons
800
roughly
newtons
ish of sort of driving force. So yeah, really sort of increasing the capability of XTS.
And it moves into new markets. The bottom line is that this increased load capacity now moves us into a whole new market, potentially whole new markets.
Thanks, Brad. Okay, so that's high drive. So that's at the heavy end of the scale. We're going to look at the opposite end of the scale now, which is the Agile system. So very sort of small, light loads, but incredibly dynamic. And I'm going to be welcoming on Chris Knight, our XTS product specialist. Okay, so I'm very pleased to be welcoming Chris Knight on stage with me now. Beckhoff UK XTS product specialist.
That's the one.
Got that right. Okay,
yep.
Fantastic. So we just looked at high drive, and now we're going to switch to the opposite end of the scale, looking at the Agile system, which is really all about high dynamics with low load type applications. Mm-hmm. So what this is all about is basically we've looked at Newton's second law of motion, which is force equals mass times acceleration. So what we've done is basically chopped out loads of mass so we can actually increase the acceleration. So the smallest standard Hepco mover that we do on the standard XTS is 610 grams. The Agile mover has dropped right down to 250 grams. How have we done that? Okay, so we've got a smaller bodied mover. It's lower. We've included lots of machining in the body, so we've taken material out as much as we can without compromising the stiffness or strength of the mover. And we've also developed a smaller diameter bearing, so it has lower inertia, allowing us to basically spin it up quicker and achieve higher accelerations. So what does this mean in terms of actual performance? Linear speeds of 6 meters per second and decelerations of about 20 G. So this is really sort of maximised performance, isn't it, Chris?
Absolutely. Does any of that affect the actual track that it runs on?
So no, the track that we use, and I'm pointing to the track management system there, but the Agile system uses exactly the same track itself as the standard XTS, but there is a small difference in terms of how we mount your XTS motors. Okay. Because it's a smaller mover, we've actually had to adjust the height of your motors. But fundamentally, the principle is exactly the same. So in terms of actually driving these movers, what sort of challenges does it present to you, and you know, how does it affect the accuracy and repeatability by stop and starting much quicker?
I mean, in principle, it doesn't actually affect an awful lot of what you do when you configure an XTS system. So you still use the exact same twin cat operating system, you still use the exact same XTS configurator, and you use the exact same PLC code to actually drive the movers around, as we said, independently of each other. What has changed because of the mechanical changes you've made is obviously the acceleration switch you can go, so you have to be a lot more careful with how you're starting and stopping things, but you still maintain the repeatability, even in that condition. And you have to be aware that the systems can run much closer together. So this is another main benefit of this system, is we can actually run them now with a 55mm pitch between two mover centers. So you can gather those movers together incredibly close, should you have to, for a particular machining application. We use the 4-pole magnet system on this mover, which means that you're using less force, so you've only got 70 newtons. But that still means that you're reducing the amount of energy consumption of your system while maintaining those high accelerations and decelerations, as you say. Okay, so this is the eco-friendly version of the XTS then. So yeah, obviously we are at the opposite end of the scale from the high drive. So the payload is very much reduced. We're aiming at sort of maximum payloads of up to 250 grams. So this is really sort of aimed at applications, high yield,
low mass, so something like a plastic syringe body, manufacture blister packs in pharmaceuticals, small lightweight cosmetics, where you really want to maximize your throughput of the product through the system. You know, because effectively when you think about it, when you're transferring your product from one process station to another, that's all lost time. It's dead time,
Absolutely.
dead money. So you want to throw it out as fast as possible. In terms of actual sort of throughput, we are looking at numbers of say 500 to 800 parts per minute if we're indexing. Continuous motion,
Over
1,000. Yeah. So we're really shifting with this system. So yeah, that's Agile in a nutshell. And we're now going to move on and look at our track management system.
Okay, so we've looked at already how we can push the boundaries of XTS, GFX technology in terms of the amount of mass that the system can carry. We've just covered the amount of the velocity at which we can move and the acceleration we can achieve with the new Agile Mover. So our next topic is to look at track management system. The 3,000 systems that you heard about earlier that are in existence at the minute are all single track systems. And we need to essentially get around that limitation. But why would we want to do that, Alec?
Yeah, I mean, it's a great challenge. And why would you want to switch between tracks? Now, fundamentally, what this means is that we don't have to remove the product from the mover, which is incredibly crucial in some applications. All of this has been, as always, customer driven, hasn't it, Chris?
Absolutely.
So, yeah, effectively you can transfer a mover from one XTS track system to another without it actually leaving a single process line. So this means that we could, for instance, take the mover to a rework station, maybe offline inspection, maybe a complete zero maintenance system where you can just swap out movers and never have to stop. How about that?
That would be incredibly good, yes.
So there are lots of applications, but effectively what you can do is you're removing the need for a separate robot or a pick and place system to transfer product from one line to another. It's all done by this incredibly clever track management system. Chris, how does it actually work?
So essentially you still use the same twin cat technology. We have a second set of function blocks that allow you to identify in a track management system where a mover actually is. Fundamentally, XTS is a collection of, as you were told earlier, servo motor sections that are connected together to make a track. Each one of those is connected by an EtherCAT network, and we define each of those networks as a part in this track management system. And what we can then do is assign those parts to a particular track. So, for example, completing a circuit by moving a mover module up and down in between the tracks, we can then define that as track 1. When a second unit is moved in there, we can define that as track 2. And all we really do then is essentially tell the mover where it is on each one of those tracks at any particular given moment, depending on where the switch is positioned on the system, which is a Hepco creation on the system behind us.
Yeah, and you know, that in itself hasn't been easy, because to switch from one track to another and, you know, keep it pretty much seamless, we need to be able to shuttle the track management switch system within microns, effectively. If we're out by, you know, more than sort of 5 microns or so, it's going to sound like a nasty old clunky train track. So we use a clever sort of ball screw driven system with a servo motor that's connected to your drives and controls, and a linear encoder which allows for thermal compensation as well. So as the ambient temperature changes, or the temperature that the XTS generates, it all compensates for that and means that we get very, very repeatable switching over millions of cycles.
And are we limited to a single motor module on those switches, or can we go bigger?
So yeah, in terms of the modules, the example we've got behind us is a single motor example switching between just 2 levels. We can go up to 2 motor modules, and you could go 3, 4 plus levels in terms of the switch. Now, the only thing to bear in mind is the longer your travel distance, that does slow down the transfer time. But something like this, you could be looking at switching in 0.4 seconds.
But of course, that would then, if you had multiple switches, allow you to do some sort of accumulation application as well. So it would allow you to gather your parts together off the main track, so your main process can continue, but actually hold product in a particular place if it needs to be, say, reworked, or if it needs to go back to a previous station, for example. Yeah,
so this is, again, as Chris said, really sort of pushing the boundaries of XTS, GFX, and is pretty much ready to go in terms of applications. So yeah, that's a track management system. And next up, we're going to take a look at a fascinating technology called NCT. But before we do that, I just want to urge you to once again drop your questions into the question module, because we'll be taking your Q&As after the next section. Okay, so we're once again going to be relying on Chris's expertise for NCT, or no cable technology, which again to me seems like complete magic. You've got effectively a passive mover and effectively bringing power to that mover, so you can actually have an actuator, or some sort of electromagnetic inductive device, gripper, to effectively perform functions on the mover. Now, I know from a mechanical engineering perspective, that is an incredibly difficult thing to overcome. You know, if you do it mechanically, you need bus bars or some sort of complicated concertina type wiring device, and if you're spinning round and round, it's going to get tangled up at some point.
Yeah.
So how did you do it?
Well, essentially it solves the problem, as you say, of having passive movers. So the big problem we have with XTS applications is that using passive movers forces us to do gripping applications by bunching movers together and having them with mechanical actuators that allow us to then clamp something and use the movers to actually perform the clamping action. Okay, NCT is a step on from that, where we actually transfer power to the mover directly using an electromagnetic induction. So similar to how you charge your phone on those little drop pads now, or like an induction oven, think of it like that. We're able to transmit not only power but communications as well. That's the main thing. So we can actually transmit up to 3 amps worth of power at 24 volts across the gap between the motor module and the mover, which means not only can we run sensors, but we can actually also run actuators, as you say. So a standard application for us for clamping or for gripping any sort of product actually allows us now to place a clamp or a inductive gripper onto the mover and then use that. So we now have reduced the footprint again by half, because we don't need 2 movers to perform that action anymore. We can just get away with 1. And this update rate of this system is about 4 kilohertz, so we can send information back up to the PLC controller in real time, which means we can then actually make decisions based on what's happening in real time on the real system as the mover is going round.
So, I mean, yeah, it does seem like magic to me. But does that affect the performance of the XTS in any way? And does it need different sort of motor modules?
So no, it doesn't affect the performance we've already discussed in terms of the speed and acceleration. What it does affect is the motor modules. So we have a new motor module with an extra section on it that provides this electromagnetic induction technology and allows us to transmit this communication and power across to the mover. But the benefit of going to that is obviously then you reduce the number of movers still in your application to provide the same thing, and you can also remove a lot of extra apparatus around the machine. So for pick and place applications, you suddenly don't need Delta robots with their drives. You can use the XTS with a gripper mounted on a set of movers to perform the same sort of tasks. But the benefit is these can also be retrofitted. so older systems. So the motor module itself is completely interchangeable with the current existing modules. So we can actually then have systems that are part NCT and part standard XTS systems.
Thank you, Chris. And just to add, NCT is compatible with Hepco's Mover, so you can use the Hepco guide system, giving you that added capacity on sort of high load, high sort of durability applications. So yeah, that is NCT. We've looked at several subjects today, so the high drive, the agile system, track management, NCT. So lots of stuff to talk about. We'd love to hear your questions. So yeah, we'll move over to the question section now. Thank you. Okay, thanks. We're back again, and we've got beverage of choice here, haven't we, chaps? Non-alcoholic, I might show you as well. So, okay, right. Well, thank you for bearing with us. We're going to leap right into your questions now. Thank you so much for the questions. Thank you so much for watching. And guys, we're going to try and do our very best to answer these questions. First one, I'll chuck over to you, Brad. You're quite a cool customer. And this one is asking about the operating temperatures that we could run XTS applications in the possibility of extreme low temperatures.
So no is the answer to that. We have 0 to 40 degrees, which are standard electronics, which is within the motor modules. So we are rated at 0 to 40 degrees. So anything below that is not recommended, or certainly not certified.
Okay, thank you. Next one, I'll probably pick this one up. Lightweight movers are aluminium based. How sure are you about the impact of cleaning fluids? So that's a quite a pertinent question. We know that there are processes out there which involved sort of clean downs and such like. There is a solution which is being worked on. It's in development, and it's called Hygienic System, and there will be 2 versions of that, actually 3 versions, because you guys do an aseptic version as well. But with the Hepco track, there will be a clean down, what we sort of call a wipe down version, and a wash down as well. We haven't really got much to sort of include on that one today, which is why we've not featured it, but it is being worked on, and should be available sometime in the future.
So that would be, can I jump in there?
That
would be rated at IP69K.
Yeah, and in terms of the, going back to your original question, in terms of the aluminium, the construction of the Hepco movers, it uses a hard anodized finish. So it's extremely durable in terms of the carriage. The bearings and the track will be stainless steel as well. So it gives you the maximum sort of resistance to these chemicals. But saying that, the mix of chemicals and the strength or potency of the chemical is very important. So when we look at these applications, we will always ask you exactly what you're planning on putting on the system. Okay, next up, Chris, this looks a bit technical. So you're the official XTS guru here, so I'm going to throw it over to you.
Okay.
Can the PC be used to program the whole system, or is it necessary to use another PC or PLC?
Okay, well, the answer to that is either, essentially. So with the XTS, you're typically talking about a Beckhoff C60, C69, or one of our big C6670 IPCs, all of which run a full version of Windows and will allow you to install our TwinCat development environment onto them directly. So you can program directly on your own laptop, or you could run it directly on the IPC that's going to run the XTS itself. That's entirely up to you, and whatever process works best for yourselves. TwinCat is obviously the development environment supplied by Beckhoff that XTS is programmed in, which you can download from our website, and it's completely free to download. The XTS tools are completely free to test in trial. So get out there and get cracking with it.
So just to reinforce as well, we have a simulation tool which runs in the tools that Chris has just said, but also the PLC or any other robotics or any other motion control system will run on the same automation platform, i.e. the same PC as the XTS. So you do not need extra hardware.
Excellent. So basically what you guys are saying then is that effectively when our customers are looking at a potential application, they could effectively map it out all in the software first before we even start doing anything with mechanical hardware.
Exactly right. And with the simulation builder and the PLC being able to run in simulation mode, you could actually have the entire operation entirely programmed out and running in simulation before you even touch hardware.
Fantastic. Sounds great. Okay, next question up. Alan's just asking, could you confirm the name of the Hepco fast solution up to 20G accelerations? Yeah, absolutely, Alan. It's the Agile system. So Agile is the name to remember because of that Agile performance in terms of acceleration, deceleration, and increased speeds. Okay, next one is question on the Beckhoff movers. Higher acceleration and deceleration produces heat in the system. Is this a problem? Has it been looked into in terms of preventing damage to the magnets and movers? Chris, do you want to have a go at that?
Sure. So yes, we looked at the how heat is produced in the system. Obviously, as you accelerate and decelerate, you draw current or regenerate internally inside the motor modules as DC link. That actually runs the motor coils and provides the motive force. So as you motor, you draw current from that, and as you decelerate, you generate back to it, which obviously then is the heat generation process you're talking about. The construction of the motor module includes a set of metal body underneath, which draws all the heat down away from the mover and onto the bed, where Hepco takes over with their PRT2 system. The aluminium construction of that then pulls the heat completely away from the motor module, protecting that and allowing you to run much higher dynamic systems than you would otherwise be able to do.
Yeah, and I think it's also that segues nicely into another little development which we haven't really touched on today, but we've got the liquid cooling modules which can be fitted onto the aluminium motor brackets, and they are in fact retrofittable as well. So if you decided to suddenly start working your XTS a little bit harder and we're encountering some overheat challenges, then you could retrofit these modules and provide additional cooling. Okay, next one is from Christopher, and he's saying, hey guys, great seminar so far. Thank you very much, Christopher. Am I correct in assuming that the systems are suitable for clean room applications? Christopher, not per se, but we have had XTS GFX systems used in clean room applications, and obviously there are many grades of clean room applications. I know of one that went into, I believe, a classroom clean 8, which is, you know, down towards the bottom of the scale. But what the customer did was actually shroud the system with sort of covers as best as possible, and use a vacuum extraction system which prevented any sort of particulates from the mechanical moving parts going out into the atmosphere. So yeah, it's not classed as clean room suitable, but you can mitigate it to operate in certain circumstances. Okay, next one, sorry. Next question. Hi, this is Kashlik from India. Hi to Kashlik in India. Very pleased that you're joining us today. My question is, how independent mover is advantageous in terms of cycle time? If an automation line has multiple stations with varying cycle times, the cycle time of the entire line will be the same of that station that takes the longest. So that's a very interesting question. Yes, you're right. So mechanically linked systems, what you've got to think about is if all the carriages or movers are moving together simultaneously. And yes, if you have a process that is taking let's say 10 seconds, then every single carriage or mover around the system has to stop for 10 seconds. Now, where XTS has a significant advantage is that, yes, you might have that one station that's taking 10 seconds, but what you can do is all the other stations behind it, you could potentially bring all of the products up behind that station and have an accumulation zone, which basically then limits the amount of travel time that you're taking between station to station. Or what is often done when you've got a process which takes a long time, such as 10 seconds, is that you can have multiple of those stations. So let's say we're filling a bottle of conditioner. I know my wife's conditioner, it's a real horrible gloopy stuff. It must take ages to put in those bottles. Sorry guys. But the fact is you could have multiple of those filling stations, and then that basically the XTS can bring in product bottles, fill them, and move on. Anything else to add to that?
No, I think in essence.
The other thing also to add to that, from my perspective, obviously, as you've just watched this video, you've been introduced to the track management system now, which gives you the ability to take things that are slow processes, reworks, retoolings, etc., and take them off the production line onto a separate XTS track whilst allowing your standard production to run. And if you do have that one process that absolutely has to run at 10 seconds, then you can use the track management to create an accumulation zone, so the stuff coming behind it is able to then accumulate in that area without taking up a huge space in your factory.
Great, thanks, Chris. Okay, next up, Santosh it's a question to me. Okay. Question to Alex. So, how the guide system is preventing the friction for high acceleration and higher speeds? What is the coefficient of friction? Okay, so the movers. There's a really good point. The movers comprise of concentric and eccentric bearings. Okay, so the concentric forms the fixed datum, and we have the adjustable eccentrics, which allows us to very accurately adjust the preload. And when we set these systems in the factory, we do a very accurate pull test, and we make sure that every single mover around the system is set to the same preload. What this means is that the drive force that the XTS control system has to generate is very consistent from one mover to another. So you're not having to push one mover harder than the other. Acceleration and deceleration doesn't really have an effect on the friction. Okay. So the actual coefficient of friction of a V-guide system is 0.03. So it's pretty low because we only have a point contact between the bearing and the V. So it's very low friction and very, very consistent in terms of its contact points. Anything to add in terms of friction there, guys?
No, I'm good.
Perfect. Okay. Another question asking, can you clean this system with water? Brad, anything else to add on hygiene?
This particular system, no. I mean, you could wipe it. It's an IP65 assembled. So within that IP rating, you can wipe it down with a damp cloth, for instance. But if you're looking for anything more aggressive, you need to wait for our IP69K version, which is in development at the moment.
Okay, great. So I might have skipped a question there. How do the two transport systems, one above the other, increase the speed? So you're referring to the high drive system or high drive plus, where we have two tracks, one stacked above the other. Fundamentally, it doesn't increase the speed. The speed is the same as a standard XTS system. So we can achieve a peak of 4 meters per second and about 10 G acceleration. But fundamentally, what we can do is take a higher mass and still move it at those speeds and accelerations within reason. I talked about a theoretical maximum of 20 kilograms. In most applications, we wouldn't be looking anywhere close to that mass. It would probably be about half that. It is probably a more realistic working figure, I would suggest.
Within those dynamics.
Yeah, within those dynamics. Okay. Right. Okay. Another question. Hi, which radiuses are possible with the bends with high drive? Okay. So high drive is essentially what we're doing in terms of not only the movers themselves, but the magnets. And I think one of the key points to mention is that, yes, we have this PRT2 based version, which is based on our 674 millimeter diameter ring, but you can also have an option for the high drive within the more compact, what we're calling the 180 degree one track light version. Yeah. So this one, I think the diameter is about 324 millimeters or somewhere close to that. And essentially it uses the same mover and bearings, but we can actually fit it with one of Beckhoff's larger motors, so magnets. So instead of a 5-pole, a 7-pole. And perhaps you want to talk a little bit about that, Chris?
So to enable the high drive technology, we essentially increase the number of magnets we have on each mover. What that lets us do, obviously, through the magnetic coupling, is increase the forces we're able to apply to the mover itself. One of the interesting side effects of that is as we actually produce the force over a wider range of coils, it's actually a more efficient way of generating the force. We use less energy for the same force when we do this. For the high drive plus, we use the 10 magnet system, which gives you the 210 newtons, peak force, which is up obviously from the 100 newtons you'd have on the standard 5 magnet. The high drive can take the 7 magnet system, so running on the standard mover on our standard systems to enable the clothoid use, and that gets you at the 170 Newton range.
Great, thanks, Chris. Okay, next question. Is there a track management system available for the high drive system? This is from Mike. Mike, yeah, hello, Mike. So feasibly, we could take a high drive mover with 10-pole magnet, the B40 bearings, and fit it onto a track management system. We haven't done it yet, but that's not to say that we can't. We could equally do it with an agile system as well. Again, the design doesn't exist yet, but there's no reason physically why we couldn't do it. I think, yeah, the only sort of one that we probably can do it with is hygienic. Yes. So yeah, pretty straightforward answer there, hopefully. Okay, next one. Can one use the motion designer from Beckhoff for such systems?
That'd be a question for me.
Yes, yeah, Chris.
The very simple answer is no. Yeah. The motion designer is designed to run for our servo drive systems, our standard motors, steppers and servos and so on. It's not built for XTS. When you do an XTS project, we actually have a set of sheets that we go through to get the application information from yourselves and understand how the system's going to respond in terms of current, heat and so on. We also have a set of numbers that Hepco themselves need to calculate the lifetime on the track. And we work that way with yourselves to generate a working system. Great,
thanks, Chris. Possibly another one for you. Jamie is asking, can we still use the Mover 1 flag with these new rails and movers?
Yeah, the simple answer is yes, Jamie, you can still use the Mover 1 flag. In fact, the TMS track behind us is using the Mover 1 flag.
Okay, next one. Barry is asking, does the load on the movers still affect the acceleration and speed? Barry, yes, absolutely it does. As I sort of mentioned in the piece earlier, we're very much affected by physics, specifically Newton's second law of motion. And basically, the more mass that we stick on the mover, the more force it's required and generates when we start throwing it around the corners and things like that. So generally, the higher the mass that is put on the mover, then from a mechanical perspective, we have to move it slower. Chris, again, I'm going to throw it to you. How does it affect, more mass affect it in a electrical drive?
Well, from the electrical side, obviously, it's still down to F equals MA. And from our side of it, it's the A is equal to current, essentially. So the harder you need to drive it in acceleration deceleration, the more current we have to use to do it. And it's just a case of working within those the forces available to you for the magnet pack you've chosen. So a standard magnet, a 5-pole magnet system has 30 newtons continuous and 100 newtons peak force. So as long as we stay within that continuous area, we can accelerate and decelerate as hard as you like for as long as you like, essentially. Once we move into the peak region, that's when it's the standard servo issues start to come up, and you have your I²T to consider. But we've already talked about water cooling and other mitigations for that as well.
Yeah, and going back to the mechanical aspect, then we have to consider life as well. When we look at these systems, we go through a very detailed specification process. We need to understand where your mass is, and all of the acceleration, deceleration, that has an effect on the life of the guide system as well. But we can do all those calculations and provide you with an accurate life figure when we're at the whole sort of specification phase. Okay, next one. Brad, what's the typical repeatability and accuracy of XTS systems?
150 micron.
At 1 meter a second.
Yeah.
And 50 microns, 50 microns repeatability.
Okay, and then another question from Barry. Is the XTS system also used in the food industry? Barry, I mean, yes, absolutely it is. Yeah, I mean, it's been used multiple times in the food industry for many applications. We did touch on hygienic, which again we haven't really talked much about today. But beyond that, there are systems out there, standard systems that are working in the food industry. As standard, Hepco can provide these systems with a stainless steel guide and bearings. The AS bearings that we fit to the movers are filled with a food grade grease as standard, and the lubrication that we use for our bleed lubrication system that goes on the track, you can basically change the specification to whatever you need as long as you're maintaining the viscosity. That's the important thing, so we get the right amount sort of spread around the track. Okay. Yeah, just moving on. We're getting towards the end of the questions now. So if there are any final ones, please drop them in and we'll do our best to answer them. Brad, next one. There's a question asking, how many systems do we actually have running in production today?
Well, the number's rising, but 3,000, over 3,000 systems running in real production environments. That's where we are today. We are shipping, is it 1 a week?
3 a week.
It's 3 a week. We're shipping 3 a week, 3 systems a week to our OEM base currently. So that number is rapidly rising. But yeah, 3,000 essentially plus.
Yeah, and certainly, in terms of the, the Hepco GFX system, many of these systems we've worked together with Beckoff.
Yeah.
And it's what provides the durability and the extended life of these systems. Okay, next question. What is the specification of the XTS GFX system? Do you guys
Specification process?
Yeah, specification process.
So I touched on this a little bit earlier. We tend to do, or we try to do as far as possible, to have an XTS GFX development as a partnership between yourselves and us. So you would work together with Beckoff and Hepco in cooperation to actually understand the requirements you have for your system. We would then take that down, and this is the things like the load, the inertia of the mass and the tooling you're going to mount, the speeds you want to achieve, the accelerations, your transit time between stations or operations, for example, the amount of time you're going to be running per day, per week for Hepco for the rail systems. And we would work with you to, with those numbers, to produce you a system that you could then implement directly yourselves. And yeah, that's pretty much it from our side.
Yeah, and yeah, just for sort of going back over what I said earlier in terms of the mechanics, then it's obviously all of the things that Chris just mentioned. The distance between your stations, the time that you've got to do there to move between stations, because that effectively dictates your acceleration and deceleration, which creates force, which is transmitted through our mover. And of course, the mass, the actual physical mass that you're putting on the mover is incredibly important. And also very important is where you put that mass. So the further outside of the track, you know, the offset loads that you do it, then effectively the more force that it creates on the mover. You know, it creates a torque. So, you know, when you're designing these systems, it's good practice to try and keep the load as central as possible on your mover.
Mm-hmm.
Okay, a few more questions popping in. These guys are still going strong. So, how does the XTS perform in dusty applications? Well, I'll kick off with that first. And you know, sort of at the early part of this show, I mentioned about the V guide that this is based on, that Hepco have been doing for 50 years. And one of its inherent benefits is the fact that it works extremely well in dirty and dusty conditions. The V guide has a differential in diameters between the bottom of the V and the outer of the V. And as it spins and rotates on the guide, it basically scrapes forward any dust and debris and pushes it out of the way. Brad, do you want to mention anything about the XTS motor modules?
Only in so much of the IP rating. So just to reinforce, it's IP65. In terms of dusty environments, we have a large number of them running in food factories and in automation, automotive. So, you know, general dust and general industrial environment, that's what it's built for. So I don't have. Chris, do you have any?
I think from our side, obviously, the contact part's done by Hepco. So the motor modules that we have, Hepco's track maintains a constant air gap around our magnet. So unless you were to drop something in there significantly larger than that air gap, there'd be no issue at all.
Yeah. Excellent. Cool. Thanks, guys. Chris, do you have a go, no-go calculator online? I don't know what that means, but I'm hoping you do.
Yeah. I'm assuming they mean a project go, no-go, a designer. So as I said to one of the previous questions, no. If you want to find out about these systems, you can get in touch with your local Hepco or Beckhoff contact. They will then engage with you to sort of talk over your application. They also will have a document that will be sent to you, which is then the go, no-go tool, which allows you to enter the values we talked about earlier, so your masses, etc., and then find out the from your designed profile of how you intend to move, whether that is then possible or not. We were then able to manipulate the sheets through Beckhoff or Hepco help. For example, choosing different mover types that are more robust or more or less mass and therefore stiffness and so on. Or from our side, more motor modules in certain positions to share power across a system, for example, so more motor modules in areas where you have lots of movers accelerating harshly at the same time, you'd want more motor modules there, for example.
Great. But the basic specifications are on our website. Mm-hmm. So in terms of peak forces of all our magnet packs and our drives. Yes. So that's not a bad starting place, really.
Mm-hmm. Excellent. Thanks, guys. Here's a great question. Santosh is asking, how did Beckhoff start operations with HepcoMotion and when? Well, I'll kick that off. I mean, it's a great story. All started back in 2015. So what's that? Over 7 years ago now. And effectively, it was a very challenging and demanding application. You know, customers are always pushing technology further, and that's what drives innovation and development. And that's very much what happened in this instance. So there was an application that was incredibly high speed, high throughput, and Hepco and Beckhoff started working together to come up with a solution that was effectively durable enough to give the customer the life they needed. So the GFX system that we designed back then is much different from these beauties that you see today. It was an incredibly onerous process in making a monolithic design. Effectively, the track and the base plate was all made out of one piece, but it was still based on the V technology that we're using now. And in fact, that system only retired from duty last year. So it did 6.5 years of work. And there's all sorts of fun stats, like in 1 year, a single mover did the equivalent distance from here to the moon and back. And so, yeah, it's been a great journey. And I think, you know, there are many systems now that combine our technologies.
Absolutely. Yeah.
Anything else to add on that, guys?
Not from no.
Brilliant answer.
Pretty, yeah.
Okay, perfect. Right. Here's a good one. Chris, you love a challenge, don't you? Can the current that you use for the mover be used to detect a mass on the carriage, or for weighing a mass on the carriage?
In principle, yes. So one of the benefits of the Hepco design is that their mover actually takes the load, essentially, of the load off our system, so the actual motor module doesn't bear that. And so essentially, from our perspective, all we're doing is a pushing force. Therefore, in principle, you could use the current feedback to detect a change in mass that you're actually moving, because obviously it will all come back to F equals ma at the end of the day. So the higher the acceleration, the higher the current, you'll be able to detect an extra mass on that, or lack of, should you have lost your product.
Okay, that's great. Well, thank you very much, guys. We're going to wrap it up there. Thank you ever so much for joining us today. Chris, thank you for your expertise.
Pleasure.
Brad, thank you for your expertise as well. And thank you for hosting us here in Huntingdon. So thank you all, and we really look forward to seeing you again very soon. Be sure to check out our social media, website, YouTube, etc., both Beckhoff and Hepco. Thank you very much. See you again.